In this video, we'll study about the chapter Gravitation in class 11th. The first topic is Newton's universal law of gravitation. This law states that between any two objects in the universe, again two objects M1 and M2, it states that between any two objects in the universe, there is always a force of attraction, and that force of attraction that is proportional to the product of their masses and is inversely proportional to the square of the distance between them. If r is the distance between them, then this is inversely proportional to square of distance between them. Newton's universal law of gravitation states that between any two objects in the universe, there is a force of attraction. That force of attraction is proportional to the product of their masses and inversely proportional to the square of distance between them. Now we remove this sign, we put a constant here. This is F is equal to G M1 M2 upon R square. This G is called universal constant because it is same, its value is same everywhere and is independent of the medium. And its value is G is equal to 6.67 into 10 to the power minus 11, and this Newton meter square per kilogram square. Now this, because of this value is very small, this force is not evident in our day-to-day life. We do not experience it, we do not feel it. Now this is evident where? In the case of rotation of Earth around Sun, the rotation of Moon, the revolution of Moon around Earth. In the same manner, why tides are formed? It is because of the attraction between the ocean water and the moon. So they all are the examples of Newton's law of gravitation. The G is very small. Now how to define this G? For definition, what we do? I'm making mass M1 is equal to M2 is equal to 1 kilogram and R is 1 meter. Now this is 1 kilogram, 1 kilogram, 1 kilogram. We can say that G is equal to F. Now for definition, gravitational constant is numerically equal to the force of attraction between two objects of unit mass which are placed at unit distance apart. Again I am repeating it. Gravitational constant is numerically equal to force of attraction between two objects of unit mass which are placed at unit distance apart. By this you can define G. Or sometimes they ask you write Newton's law of gravitation in vector form. In vector form, just write down here F12, put an arrow here, and here R12 unit vector. Now F12 means what? This is not F12. This means what? Force acting on first object due to second. Or you can write or F21 is equal to G M1 M2 upon R square. This is R21 unit vector. These are unit vectors. This gives a direction. Alright. F21 means what? Is the force acting on second object due to first. This is your Newton's law of gravitation in vector form. Now, taking the example of Earth and any object on the surface of Earth. Suppose this is your Earth. Its mass ME I am taking, ME the mass of Earth. Its radius RE. Any object on the surface of Earth, suppose its mass is small m. Now by Newton's law of gravitation, the force of attraction between these two objects, one is Earth and another an object on the surface of Earth. So this will be F is equal to G M1 M2 upon R square. M1 is mass of Earth, M2 is any object on the surface of Earth, and the distance between them is radius of Earth. So this is the force by which the Earth attracts this object of mass m, which is kept on the surface of Earth. Now you must have studied the force by which the Earth attracts a body towards its center. That is called its weight. Now if G is the small g is the extension due to gravity, Then what is weight? It is mg. This is by force of attraction, Newton's law, and this force is equal to the weight of the object. Therefore, this is equal to mg. This g is universal constant. This is same everywhere. Now this small g is what? This is acceleration due to gravity. That means what? The acceleration which when a object is dropped freely, the acceleration produced in that body is called acceleration due to gravity. Okay. This is mg. So g is equal to g me upon re square. Now, important thing to note that this acceleration due to gravity, it is independent of the mass of the object. That means what? It acts same on all the objects. It only depends on mass of Earth and the radius of the Earth. Sometimes they ask you find the mass of Earth. So using this formula, we can find out mass me is equal to g re square upon capital G. M is g re square, mass g r square upon capital G. Sometimes the question is what is the density of the Earth? We can replace mass in terms of volume into density. Now volume is 4 by 3 pi re cube. The volume sphere, its formula 4 by 3 pi re cube multiplied by its density of Earth. So this is g re square upon capital G. R square, this cancels. You want density, the density will be, this is 3g upon 4 pi reg. So by this formula you can find out the density of the Earth. Okay? This is the formula for mass, this is the formula for density.